Hey, what's up guys? My name is the Cherno. Welcome back to my game engine series. So last time we talked about transforms, we added them to our 2D renderer. Check out that video if you haven't already. And now that we can actually position these things anywhere in our screen and inside our kind of level and also set random sizes to it, the next logical step is to take a look at textures and how we can actually render these as textured quads, because at the moment all we can do really is set a different color for them. And whilst that's kind of cool and you can have this little game with no textures and just colors, and you can still do a lot with that. Obviously in kind of the real world we want to extend this engine so that it supports textures, especially since the engine does support textures, it's just the renderer doesn't yet. So what we'll do today is kind of discuss textures, how we can set them up for our renderer, and yeah, we'll just add that in and make it work. But first I want to give a huge thank you, of course, to all of the patrons that made this series possible. Patreon.com/thecherno is the best place to help support this series and my channel and everything that I'm doing here. If you guys aren't interested in this 2D stuff, you want to kind of progress to 3D and take a look at that, I do have like a full 3D renderer going on in that Hazel development branch with like a viewer layer so that you can control like textures, models, all that fun stuff. And in fact, I do want to make more videos in the future regarding specifically what I'm doing to that development branch, just so that you guys get a little bit more insight into that. On Patreon as well, I've also got exclusive videos just detailing where this series is kind of going, what I'm doing, what's planned for the next episodes. I also show stuff from the Hazel development branch, such as multi-threading and all of that stuff that I'm currently working on as exclusive videos. So definitely check that out if you're interested and help support this series. Okay, so textures. Where shall we begin with that? So this was the current setup that we left off in the last episode. We can now position these, which is lovely. What I'm going to do now is extend draw quad. If we look at this function, extend draw quad essentially to not just take in a color, but also take in a texture. And that's pretty easy to do. I'll duplicate both of these functions. Instead of color, we'll simply take in a texture. So this will be a const ref texture 2D. And then we'll just have texture over here. We'll include texture. And then I'm gonna, of course, copy this and replace it with this. And that's pretty much it as far as the functions go. Same exact functions, 2D or 3D position. And then we have our texture here. What I'll do is copy these and then come over here into the CPP file, paste them in, and just implement these functions like this. I'll also grab this renderer 2D namespace, of course, put that in, and get rid of the static keyword. Okay, cool, so we have these functions now. Similarly, how we did with this draw quad, our kind of 2D, or our vec2 draw quad will actually call the vec3 draw quad. So what we'll do is initialize that with 0 and then just pass in the texture there. Okay, and now we have this. This is what we're gonna be working with. Now, initially, I'm gonna copy and paste everything that draw quad actually has, because that's pretty much what we need to deal with. Except instead of us setting a float 4 color, we're actually going to set a texture. Now this is also where this becomes a little bit interesting and you might want to do it differently. It's useful, I will say, and in fact some people like doing this. You can actually have both. So you can have a color and a texture. And what happens is they get multiplied together inside your fragment shader. So what that means is that you can basically set the color to white if you just want the texture normally. But if you want to like darken the texture, like fade it out or something like that, so you can kind of fade it in over time, you can just have, that white color. And then maybe set its alpha accordingly. So you can have like the alpha animate from 0 to 1 and thus it'll kind of fade in. Or you can have it fade from black if you animate the color from like, 0 on all channels all the way to 1 on all channels. Or you can tint it red by having more in the red channel. You guys kind of get the point. There's a lot you can actually do here if that's the direction you want to go in. So I'm probably going to have a function like that in the future where you could probably have both a texture and a color tint applied to it. That's also totally reasonable. It's also, like, another thing that you could do in the future to extend this is you could actually have a class or a struct that represents a 2D renderable, like a quad. So in other words, we don't have any kind of data structures, right? What we're doing right now is we're simply, every time we want to draw a quad, we have to specify the position, the size, the texture, the color, that stuff. That's all kind of just parameterized. That's what gets fed into the actual renderer 2D functions. But what you might want to do is actually create a renderable 2D or something like that, or a quad struct or class inside your actual engine code base. And then what you can do is, if you want to create that and handle that kind of on the game side, you can be like, okay, well, I've got my quad. And then if I need to like set its position or whatever, I just set the position inside the struct. I can set the color, I can set the texture, I can do whatever I want with that. And then when it comes to render, I just pass the renderer the quad. And because it's, of course, a known type to the renderer, it just gets it and it gets all the information out. That's just a different way of organizing things. You can do that. In practice, I don't think I like doing that. The reason is that I think that having too many types, we'll say, in the renderer and dealing with all that stuff just makes things unnecessarily complicated. There's nothing at all from stopping. There's nothing at all that's stopping the game side of things from actually creating a quad struct. So if you want, inside Sandbox 2D or inside your game, you can create a quad struct or a quad class or whatever, or a rectangle class that has all of that stuff in it. There's no reason not to do that if that's the way that you want to go. And then when it comes time to actually render this, you just, access all of the different members. So quad.position, quad.size, quad.texture, whatever, right? Or if you don't want to do that, you can just write another kind of function if you really want to, still inside your game layer, that's just draw quad. And then that will take in a quad, and then that will call renderer 2D draw quad with kind of, quad.position, quad.size, etc. Right? So you can do it that way. Me kind of looking at this, I don't really want to introduce my own kind of renderable 2D quad kind of class inside the actual renderer. I want to keep it simple and just have it parameterized like this. I have done that in the past with other engines and projects that I've worked on. I don't really see a reason off the top of my head right now to do this. I haven't really thought about it much longer than this camera's been rolling for though. So, maybe I'll change my mind in the future. Who knows? Especially if someone gives me a good argument. But yeah, right now I just feel like position, size, texture, keep it nice and simple. Don't have a bunch of types, because then that becomes a little bit more complicated, right? You suddenly have to create a little quad struct instance whenever you want to make something, and that just makes the code a little bit more bloated, which is something that I like to avoid. Anyway, color tinting, all of this kind of stuff. Yeah, we'll take a look at that potentially. It's not really particularly hard to do, and it lets us kind of create some cool effects without much work. So we might take a look at that. But first, let's just get those textures in and implemented. So we'll get rid of color for now and see how we can just render a texture. All right, so coming back into here, I'm just going to get rid of color. What we want to do basically is bind that texture. So we'll still keep the transform. Then we'll just do texture.bind here with the arrow, of course. And that's pretty much it. Right, so if we look at the shader that we want to be using, it is basically identical to the flat color shader, right? The only difference, in fact, the vertex shader is identical. The only difference here is that it's almost identical. It has a texture coordinate, which it passes to the fragment shader, and then we sample from a texture, of course, instead of just having that color there. So that's kind of, I guess, what we're dealing with. We should probably get rid of all these as well from the 3D renderer. We haven't looked at that yet. Anyway, maybe I'll let you guys do that via pull requests. So basically, that's it, right? The only kind of thing that we need to worry about is this texture uniform. This is something that absolutely needs to be set somewhere. So that's pretty easy to do though. Oh, we also have to load the shader in, obviously. So what I'll do is we have our flat color shader. I'm going to copy that and I'm going to add the texture shader. We'll have that happen over here. So sdata texture shader. And then this will be texture.glsl. Now we need to obviously set that uniform, so we'll have to extend the shader API a little bit as well. So we'll bind and then we'll do a set int. And then this will be u_texture, we'll set that to 0. So that's basically saying that the texture slot that sample is going to be sampling from will be texture slot 0, which is kind of our default slot. You can see that if we bind this, if we bind the texture and we don't give it a slot, that default slot is 0. So that is why we're setting 0 over here. All right, set int obviously doesn't exist. Let's make it exist. So we'll have a set int function, which just takes in an int value over here. I'll quickly grab this and go over to OpenGL shader and implement it. So we have virtual void set int override. I'll copy this part of it and then go back to our CPP file. We have set float 3. I will make a set int function and then that will just call upload uniform int name and value. Okay, cool. So there we go. We've got that now. Back inside our renderer 2D. That should be it. So now what happens is, well, before what we were doing was, of course, binding this color shader and setting the view projection. We have to do that now for both. So if we come down over here into begin scene, we also need to have this texture shader and then set its view projection, right? And then once we've done that, over here where we bind the color shader and we do the rendering, instead of binding it here, we bind the texture shader instead. Okay, and then we set, of course, the texture shader's map for. That's it, right? So we should now be able to render textured quads. Really simple stuff. So what we'll do is we'll come over here. I think Sandbox app had the original textures that we tried out. So we have like the Cherno logo and just the normal alpha texture. Let's just go with the normal kind of, and I call it alpha texture. It's a checkerboard texture. If we go, where was it? We loaded it somewhere here probably. There it is. I'll just copy this. That's our checkerboard texture. I'll make a hazel texture, texture 2D, we'll call this checkerboard texture. And then inside the CPP file, when we, inside our on-attached layer where we're doing absolutely nothing yet, we'll do that checkerboard texture. Let's see what's going on here. That looks fine. And then we'll set that equal to texture 2D create. Okay, it looks pretty good to me. And then coming down over here, what I'll do is I will call draw quad. Let's just, well, okay. For the time being, I'm gonna just render this right in the middle. Well, I guess we should have a little bit of an offset just to test if that even works. So maybe I'll push it up a little bit. I will have it as 0.5, 0.5. And then of course, instead of color, I will have this checkerboard texture, which it still thinks is a lowercase. So let's just compile this file because I think it's very confused as to what's going on. And of course it compiled successfully. It's just Visual Studio being weird as usual. Yeah, let's just run this program. Hopefully we get our checkerboard texture being drawn. Okay, cool. So we just get a gray flat color. Now, I know exactly why this has happened. It doesn't take too long to work out, especially reflecting on how everything else is drawn. But I'm going to show you guys my kind of debug process for something like this. So whenever I get a texture drawing, it's clearly bound. This is not black, meaning that the texture slot clearly has data. Also, this gray is probably the exact gray that we actually have in our checkerboard texture. If I go back over here, let's just stop this and go into our textures, look at checkerboard. So that gray that you saw rendering there is probably this gray here. So clearly something's happening. It's actually, if we go over here, let's get rid of properties. It's probably this pixel that's being rendered here. So clearly something's going on. Well, the first thing I'm suspicious of immediately is the texture coordinates. So easy to check that out. I'm going to go and instead of outputting the texture, I'm just going to output the texture coordinates. So I'll set color equals vec4 v text coords, so I'm setting them for the RG, for the red and green channels, and then I'll have 0 for the blue, and then 1 for the alpha. So let's see what those texture coordinates are set to. And of course, as I thought, the texture coordinates are wrong. They're just flat red, whereas of course they should be a gradient going from 0 to 1. So we should see a gradient from black to red along the x-axis on the bottom here, and from black to green on the y-axis. And of course, somewhere here we'll have like a mix and yellow and stuff like that. So that's not what we're seeing, which means the texture coordinates are wrong. Why are the texture coordinates wrong? Well, if we go into renderer 2D, then you can see that, of course, we're not actually setting any texture coordinates at all. This kind of vertex buffer does not have texture coordinates. It's just got texture positions. So we need to set those up. So this bottom left becomes 0, 0 as far as texture coordinates go. This is the right side of the chord. So that becomes 1 and 0. That is the top right, I believe. So that's 1, 1. And then, of course, the what is that? That's the top left. That's 0 and then 1. All right, cool. So there we go. We have our texture coordinates. Now we need to add them to the vertex buffer layout, which is really simple with this API, of course. We just do a float2 and then a text coord. This can be anything really. Okay, and then that's it. I think that we have size of square vertices here, so it should just see. And in fact, this was already sized appropriately for those texture coordinates because I think I copied it from Sandbox app. Everything looks good. Now, if we run this, we should see those texture coordinates being visualized because that's where we left our shader. All right, and as you can see, that's exactly what I was talking about. We have black to red, black to green, and black to yellow, basically, in all of our axes here. So these texture coordinates are working correctly. So now if we take a look at our shader, and we change it back to be what it was before, like this, then we should see our checkerboard texture hopefully being rendered. And as you can see, it is. There it is. Okay, cool. So now what I'll do, just to make this a little bit more interesting, is I'm going to scale it up a ton, so that it kind of acts like a background. So what I'll do here is basically, well, I'll keep the position like this. So we'll say 0, 0. But then this background, I'm going to just scale it up. So I'll make it like, well, let's just make this like 10 to begin with. Because of course we can zoom out our camera, so this is not going to be like a perfect background or anything like that. I just want to make it bigger, really. That's what I'm doing. If I was actually trying to set this as a background, I'd probably do it differently, but this should basically give us that same effect. All right, cool. So there we have it. It's huge. We can't see anything behind it at all. That's where we get to test out our other parameter. Now, if I did kind of draw it first, I'd probably see it last, as in it would be behind everything, but I don't want to do that. I still want to draw it last, but I just want to check this out. So I'll set I'll push this back. So I'll set the Z coordinate here to 0.1, which should push it back, and thus it should be behind everything else. Let's test that out. And of course we get nothing because that's pretty typical. The reason that probably happens is, will happen in this case is because we're probably not even doing any kind of depth testing. Let me take a look at what's going on inside maybe OpenGL context, or I think more likely this stuff would be inside renderer.cpp. So we do render command init, render 2D init, render command init, what does that do? Render API init. Okay, so inside there, okay, we've enabled blend. So we're going to enable some other things. We're going to enable something called GL depth test. So what this does is basically enables depth testing so that it will actually test whether or not a given pixel is supposed to be behind a pixel or in front, and if it's in front, it'll write it to the color buffer. If it's not in front, then by default, using the default depth testing function, it will just discard it. So it's important that we're also clearing that depth buffer, which we are. And now that we've enabled it, we should hopefully see everything else, our blue and red quads rendering on top of our checkerboard background. But of course we don't, which means there are some other pieces to this puzzle which I'm not seeing. So let's go back to Renderer 2D and see what's going on. Okay, so actually this should be a negative 0.1 because OpenGL does use a right-handed coordinate system, which now that I'm actually visualizing it, does mean that negative values go, yeah, there we go. Negative values actually come out of the screen. So that's why that is the case. So coordinate systems like right-handed coordinate systems, left-handed coordinate systems, that kind of stuff, we should probably talk about in the future. I'll make a note of that because it's not something that I haven't considered. It's easy to kind of forget, but it's super important, of course. So here we have it. We've got our checkerboard background. We've got this being rendered here, which looks pretty cool. You can see that the checkerboard, even though it's being blown up quite a lot, is super sharp. That's because we're using nearest filtering. So yeah, that's pretty good. The other thing that we could do, now that we've kind of blown this up to such a large scale, is actually have some fun with the scale of the texture itself. So in other words, what's happening right now is that everything's like the texture coordinates are remaining between 0 and 1, which is fine, but it means that the texture gets scaled up. The texture becomes larger. What we actually could do is multiply these texture coordinates by like 10, for example. I'll just do that in the fragment shader just to make this easier. And then you can see what that does is it makes all the squares in the checkerboard texture a lot smaller. We actually get like a higher resolution texture, and the reason that that works is because our wrapping mode, which I'm actually surprised that just worked. It looks like everything's set up correctly. We've got nearest filtering by default and wrap by default as well. If we go to OpenGL texture, we're not setting our wrapping mode at all, but you can see that our magnification filter here is GL nearest. And the other parameter that we're setting, which isn't even apparent here, is something called texture wrap S and T, which basically defines how that texture actually gets wrapped. So what happens if we exceed that 0 to 1 texture coordinate system? So by default, we've got it set to repeat. I think that's what OpenGL sets it to, if you don't set it at all. So S and T is what we should have here. But if we were to do something like GL clamp to edge or something like that, then what would happen instead is, instead of repeating that texture, instead of tiling it essentially, we would just basically repeat that edge pixel infinitely. So you can see that what happens here is we have our kind of original texture, but then the very last pixel here, which is that edge pixel, that just gets repeated all the way across. So that's obviously not what we want. By default, we do want that kind, well, for this scenario, we definitely want repeat because that means that it's tiled, and that's kind of what we would expect. So let's just launch this again and see what we get. All right, cool, there we go. So that's nice to have. Obviously right now we're just hard coding it in the shader, which isn't good because it means every texture will be kind of tiled 10 times, which isn't exactly what we want. But then the other thing that I was talking about was adding a color, which you can also do really easily. If I just basically multiply this with a color, so for example, I want to tint it red, I won't change the red channel at all, but then like the other two channels, for example, I will reduce and I'll keep the alpha at 1.0 like this. Then what I'll actually get here is a slightly red tinted checkerboard texture, and you can see it here. So there's a number of cool things you can do. This tiling kind of factor here could be added as a uniform, and so could this color. So if you want to kind of experiment with that stuff until I make that next episode, then go ahead and do that. It's a great learning exercise to kind of make this a little bit more flexible, a little bit more powerful. Anyway, I hope you guys enjoyed this video. If you did, please hit that like button. Don't forget to help support the series on Patreon, of course, because it would not be here without all those generous people supporting this. Next time, I think we'll continue on with our 2D renderer. We've got a number of exciting things to talk about, which I'm not going to reveal just yet. I will see you guys next time. Goodbye.